Hey everyone, so in this video we're going to go over the two word problems that are at the end of that density packet. Alright, so first I'm looking at number 5. Walter wants to make 100 candles in the shape of a cone for his new candle business. The mold shown below will be used to make the candles. Each mold will have a height of 8 inches and a diameter of 3 inches. Okay. So part A says determine the volume of each candle, round your answer to the nearest hundredth. All right, so they told us that every candle is in the shape of a cone. So we're gonna have to find volume of a cone. Okay, so volume of a cone is 1/3 pi r squared times the height. All right, so they told us that the height of the cone was 8 inches. And then they told us the diameter was 3 inches. So that's going to make our radius 1.5. Okay, so from there we're going to put that right into our calculator. Oops. Okay, so 1/3 times pi times 1.5 squared, and the height is 8. So we get a volume of approximately 18.8496. Okay, so now in part A, it said round your answer to the nearest hundredth. So hundredth is 2 decimal places. So every candle has a volume of 18.85 cubic inches. Okay, part B says using your answer from part A to the nearest cubic inch, what will be the total volume of 100 candles? Okay, so they want us to use our answer from part A. So we know the volume of one candle is 18.85 cubic inches. They want the volume for 100 of them. So we're just going to multiply that by 100. So the total volume for 100 candles is going to be 1,885 cubic inches. Okay, part C. Walter goes to a hobby store to buy the wax for his candles. The weight of the wax is 0.52 ounces per cubic inch. Using your answer from part B, determine the weight in ounces for 100 candles. Okay, so similar to the questions we did in the first video, when they ask for the weight, they're really asking for the mass. And the number 0.52, that represents our density. All right, because again, density is always mass, so mass is measured in ounces here, per unit volume. Here, volume is measured in cubic inches. So we know this number right here represents our density. Okay. So again, density is always mass divided by volume. So we know our density is 0.52. The mass is what we're solving for, so we're going to call that X. And we know the volume of 100 candles is 1,885. So I can set this up as a proportion, and then I'm going to cross multiply. So we get X equals 1,885 times 0.52. Okay, so we get 980.2 ounces. Okay, so the weight of 100 candles is going to be 980.2 ounces. All right, next part says, the wax at the hobby store is 10 cents per ounce. Using your answer from part C, how much will it cost Walter to buy the wax for 100 candles? Well, we know 100 candles was 980.2 ounces, and every ounce costs 10 cents. So when I multiply that, we're going to get the total cost to be $98.02. Okay, so a little bit more of an involved word problem, but not too bad if we take it step by step. All right, so let's take a look at one more of these. Okay, number 6. A snow cone consists of a paper cone completely filled with shaved ice and topped with a hemisphere of shaved ice. The inside diameter of both the cone and the hemisphere is 8.3 centimeters. The height of the cone is 10.2 centimeters. Okay, so the first part says determine the volume of the snow cone to the nearest hundredth. All right, so for the snow cone, we have the hemisphere on top, and then we have the cone on the bottom. So I'm going to find the volume of the hemisphere first. So again, a hemisphere is half of a sphere. So that formula is 1/2 times 4/3 times pi r cubed. Okay, so they tell us that the diameter is 8.3. So that's going to mean that the radius is 4.15. Okay, so I'm going to go back to my calculator, plug that in. So alpha y equals 1/2 times 4/3. Oops. Sorry. There we go. And our radius was 4.15. Okay, so 1/2 times 4/3 times pi times 4.15 cubed. So the volume of the hemisphere is approximately 149.6935. Okay, then we have the volume of the cone. So the volume of a cone is 1/3 pi r squared times the height. So this is going to be 1/3 times pi times 4.15 squared. And the height is 10.2. Okay, so when we put that in the calculator, we're going to get approximately 183.9607. Okay, so to determine the volume of the snow cone, we're going to have to take the volume of the hemisphere plus the volume of the cone. Okay, and again, in a question like this, you don't want to round your answer until the very end. So I'm going to go back to my calculator, and we're going to copy these entire decimals. So this was the volume of the hemisphere plus the volume of the cone. So if I round this number to the nearest hundredth, we get 333.65. Okay, so that's the volume of one snow cone, 333.65 cubic centimeters. All right, next part. The desired density of shaved ice is 0.697 grams per cubic centimeter. Using your answer from part A, determine the weight in grams of the shaved ice contained in the snow cone. Okay, so this is another density question. So again, density is always mass per unit volume. All right, we know that the density is 0.697. And we know that the volume is 333.65. So we can make that a proportion, and then we can cross multiply. Okay, so 333.65 times 0.697. So we get, to the nearest hundredth they wanted, 232.55. So the weight of the snow cone is 232.55 grams. Okay, part C. Using your answer from part B, determine the weight in kilograms of the shaved ice contained in 50 snow cones. Okay, so they want the weight in kilograms of 50 snow cones. So to go from grams to kilograms, there's 1,000 grams in a kilogram, so we're just going to divide by 1,000. So that's 0.23255 kilograms. All right, and then they want the weight of 50 snow cones. So we're going to multiply that number by 50. Okay, so 0.23255, because again, they want the weight in kilograms, and we're talking about 50 snow cones. So it's going to be, to the nearest hundredth, 11.63. Okay, part D, last part. The cost per kilogram of ice is $3.83. Using your answer from part C, determine and state the cost to make 50 snow cones. Okay, so we know there's 11.63 kilograms in those 50 snow cones, and the price of each kilogram is